So I'm getting ready to install this new fan assembly onto the Creality CR7. This is a near relative of the CR10, so a lot of the components we'll be talking about were actually made for the CR10, but it uses the exact same assemblies for the Hotend carriage and the Z-axis carriage on one side. The difference is the CR10, they extended this boom out, put another carriage that rides up and down a second arm. But just show real quick how this fan assembly works in comparison to the factory one. And I cannot remember off the top of my head who designed this, but I will put a link to the Thingiverse file in the description. So the factory cooling assembly is just a steel box, just a folded steel box over the top of the Hotend with a 40mm fan in it blowing directly on it. Now, one of the problems with that is that, well, it is cooling this heat sink. A lot of that air is also blowing on the top of the block, cooling this heating block, and then also flowing down around and blowing on the tip as it's printing. Well, blowing air on the tip while it's printing is sometimes desirable. Having it heated up first by blowing over the top of all this and then going down, it isn't. So this assembly focuses the air a lot more directly from the 40mm fan straight onto this heat sink. And this is the original heat sink. I have a micro Swiss heat sink in here, and I'll explain that in a second when I pull that apart. But it just clamps over the heat sink like that, uses the same bolts going through. But now, as you can see, much less of the air is blowing downwards on the heat block. Now over here you have a second fan mount for, I do believe these are called a 5020 blower fan, and it just plugs into this hole like so, bolts on. And these fans, they don't move quite as much air as a normal fan does, but they're very, very quiet. The air comes down through this, and there's some spiral veins in here going like this that cause the air to evenly spread out all the way around this and blow out the slots at the tip. Now we have nice cool air blowing on the plastic as it's being extruded, which helps with bridging and adhesion, a couple other things. But now we have control over that because this is a separate fan. We can turn the speed of this up and down to how we want it to affect the print. The air is more cleanly concentrated over the heatsink, which means we have less of the heat from the heat block traveling up into it, which is the main reason why I have this micro Swiss Hotend. These Hotends have this little tube inside. You can see it poking through in the center there. Inside the tube is a Teflon liner. Now, the Teflon liner is supposed to help as the plastic wire is being fed in, help it slide through this assembly better into the tip. But one of the problems is, if this block isn't being cooled efficiently enough, or if you try to raise the temperatures of this for more exotic materials that require higher heat to melt correctly, if you get too much heat traveling up into this block, this tube will actually release from the inside of this stainless and slide down into the heat block, where it will partially melt, but the heat is not actually high enough for the tube to be completely melted and driven out with the rest of the plastic, so the whole system clogs up and stops. And that's what's happened to this Hotend. And so in the past I've just kept a lot of these on hand and just change them out every time, but that's really getting old. So this last little heat wave we had here in the studio, where the ambient air temperature was too hot for the fan that I had before this, it everything fell apart. I actually didn't have this factory fan shroud on for quite a while. I had one of these assembled like this, blowing directly across it with a slab of plastic, preventing the air from getting out each side. And while it worked most of the time, these fans, they're just not quite efficient enough for it. So, it was time to upgrade. Now, let's get this factory box off of here. I need to save these two screws because these two screws that hold this original factory shroud on will actually help hold the new fan duct assembly on as well. And they kind of have to be the original low profile hex heads because they're going to drop into this slot and the slot inside here, and at least for this outside one, the fan is going to be installed directly over that. So it needs to be low profile so it doesn't obstruct the fan. Otherwise you might have to Dremel a little bit of the fan guard or a little bit of the fan case away. So here's the new Micro Swiss Hotend. It doesn't look hardly at all different from this other than its color, but the way they've constructed this is completely different. That tube that I mentioned before isn't in this assembly. There's still a little connection block in between there, but this is actually a piece of titanium. So it's not threaded into the block, it's held in by this set screw, and it's a very, very short piece. I'll try to insert a picture in this video of this assembly taken apart. Unfortunately, I forgot to record when I assembled this, but the block effectively isn't any different than the factory block, other than the addition of the silicone boot, which holds more of the heat into the block and prevents airflow from around it from cooling it down as much. So it comes up to temperature faster now. The idea behind the titanium piece in here, and it's machined in such a way that it fits into a cup on the bottom of it, so the plastic that's coming through here doesn't really come into contact with the titanium, at least not very much. Instead of having that tube threaded up inside this heatsink, the heatsink itself is drilled out and polished accurately to where it itself is the guide. So one of the big problems I had with the original assembly was this assembly, since it's all threaded together, unscrewing and the block turning. Well, it may not seem like a big deal, but this block turning screws in and out. Even if it's only turning a quarter turn, it can be moving up and down a couple hundredths of an inch. And when we're setting our height off the bed for the first couple layers with the thickness of a piece of paper, a couple hundredths or even a couple of thousandths makes a huge difference. And it was affecting my prints when this was coming undone during the print. As things heat up and expand, you can feel like these parts are tight when the machine's cold, and as soon as it heats up, things start wobbling. And this is what the block was doing while it was printing. So when you assemble things like this, and the instructions for this kit are very, very clear on this, once you assemble it, you need to bring everything up to temperature and then tighten all the screws down again. So, need to pull this block off. Now, thankfully, there's a slot in there, so I don't have to pull the Bowden tube off. The the filament wire is guided through the Bowden tube. This motor back here is the extruder, and it forces the wire in between a pinion gear and a ball bearing roller, and the spring pushes the ball bearing against it, so it pinches the wire and pushes it through. And this assembly, when this is separate from the hot end, is called a Bowden assembly. These tubes it feeds through are actually just industrial airline. So another thing that I'm going to be adding as soon as I get this fan shroud on is changing that out for this Capricorn tube. Capricorn tube really is just a different type of industrial airline made of a different plastic, but the important part is that the inner diameter is a lot smaller than the standard tubing that we've been using for years now. And so the wire is less prone to being able to flex and bow and spring inside it. It gets guided a lot cleaner because it doesn't have a lot of space to deviate from the center line, and which makes the feed and the retract much more even. So this is simply going to pop over like that. The heat block needs to slide up in there. It's kind of hard to show on camera because this stuff does not want to bend this direction, but and I'm immediately running into a minor problem here. This file was actually designed around the factory block, which has a little bit of a curve on the side. This Micro Swiss hot end has a much more square block, so I'm going to have to go in over the square file and sharpen these corners a little bit and try again. But while I got it out, show how both these fans look installed. And I'll be routing all the wires cleanly through this gap up through here, that way they can be zip tied to the side of this and everything can be as clean as possible. Factory block 3D printing can sometimes be a little bit of an adventure. This fan shroud has taken me 3 tries to get correct. The first time was just straight up a mistake. The second time was a very bizarre issue, and the third time finally came out okay. First problem was when I loaded the file, it loaded vertically like this, so I assumed that this was the direction that the original author intended it to be printed in. So I turned on support structure and let it print. I didn't pay enough attention to him saying that support structure should be touching build plate only, not everywhere. So it built support scaffolding between absolutely everything. Inside here, all up through here. And the worst part is this is hollow. There is support structure inside here now, and I cannot physically remove it. See, if I stick my knife in that slot, I cannot move it. It's just full of plastic scaffolding that I would never be able to break out and pick out through this hole. At least it wouldn't be worth my time. Plus the bottom, anywhere where support scaffolding is touching a print, tends to not come out great. I could sand this down, but the scaffolding on the inside is pretty much unfixable. But after looking at the way the print is designed, if you print it on its back, it requires considerably less support structure, only in a couple places, like inside here and supporting this inner crossbar that goes over the top of the hot end assembly. So that was junk, so I tried again, but I printed this one on its back and got the correct support structure, but if you look at it, something went horribly wrong. right about here. You see it also over here. Something happened here where as the bed was moving back and forth under the print head, it received a command to go one direction and then didn't come back fully. So it printed these base layers all stacked up neatly, and then all of a sudden started printing over here. So it's offset. And there's absolutely nothing I can do about that. Unfortunately, this happened literally minutes after I left the studio, and this print ran overnight. So each one of these was 14 hours. This one then went down to 13 hours because it was a little easier to print on its backside. So 2 down, third time's a charm. Finally got it right. This part came out looking pretty good. I've sanded down some of the areas where the support structure were, but the way it's designed, you don't really see hardly any of that because it's all facing downward and backward, fans mounted over it. Okay, I did a little work off camera, got this hole squared out a little bit. I actually got a little creative and I didn't want to file it all out. I don't really have a coarse file here at the studio, but I do have a scroll saw. And this just barely fit. I had to keep changing the direction of how the scroll saw blade is mounted, and unfortunately because the throat on the scroll saw is kind of narrow, I did have the head strike a few times up here and kind of mar up the surface, but we did get it squared out. One of the things is when you're taking material off of a 3D print, generally they aren't printed solid, right? You see areas like this that are fairly thick, or especially in here, you would think they're solid plastic, but in 3D printing, to save material, these spaces are actually mostly hollow, and they have like a cross-hatching grid of material inside there, kind of like a honeycomb structure. In fact, you can actually use a hex-shaped honeycomb structure, but generally it's like a square grid. And so when filing material away inside here, if you look really close, I find something to point with, you can actually see where I filed these corners from round to square, it actually started to open up into the hollow. So you got to be kind of careful with that. There's still plenty of material in this thing left. It won't really hurt anything, but we can control the percentage of that infill all the way up to 100%. We can print things completely solid if absolutely necessary, but it almost never is. So objects that look solid in 3D printing can and usually are actually hollow. So bringing it around now, well, the other thing is this little retention clip has to actually be removed because it sticks out just enough to hang up. So once that's removed and set aside, we got to make sure to get the wires on the inside of that. There's just enough room for the Bowden tube to drop in, and it should slide up into place. Granted, very begrudgingly because it's still fairly tight. Gonna bring it up to where the cooling block holes are about in the center. So these holes are oversized because they actually have to fit over the bosses, the threaded bosses on the steel mounting carriage. So now we bring it around, give it a little bit of a push. It's kind of tight. Take the original screws that came out, right back through the same holes. Now we want to make this tight, but we don't want to go overboard because we are now sandwiching a piece of plastic in between and we don't want to shatter it. Mine doesn't seem to be quite going down all the way flat, but it is mounted solid, so I'm going to assume that's a slight difference in the blocks. Okay, off camera I came up with a solution of using some slightly longer screws in these two holes and stacking up a group of 3 washers behind each one, because apparently either there's an error in the file or there's slight differences in the screw bosses on each one of these print heads. So this makes it sit level. And next challenge I realize is that this little clip for the hose retainer, there is just barely enough room to stick it through this fan shroud. I think I'll be okay, but that's going to be difficult to change the tube out in the future. So I've cut a new tube from the Capricorn tube that matches the original factory length. I've got enough to make about 2 more because the CR7 is not a very big printer.